So a large geospatial model is a special kind of AI model that enables AI to understand and support decision-making about the physical world. Whereas LLMs, which you're probably familiar with like ChatGPT or Gemini, LLMs are trained on vast amounts of words from articles in places like Wikipedia. A large geospatial model is trained on vast amounts of 3D data. So think lots and lots of imagery. It could be from satellites, could be from phones, could be from laser scanners all around the world. And that vast amount of geographic physical data allows us to train models that can support decision-making and all sorts of different questions you might have. Sort of fall into three overall categories. First is, where am I? Second is, show me something. And the third is, tell me something. So when we say, where am I? What we mean is understanding not only where you are in space, but how you're oriented in that space. So where am I specifically, and what am I looking at? Today, we can get a lot of these answers for specifically where am I in like a coarse manner from GPS. But what's special about a large geospatial model is it is able to answer at scale, where am I and how am I oriented in that space? We say orientation, but not only in 3 degrees of X, Y, and Z, but also like the actual place that your eyeballs or the camera is pointed. For show me, that has to do with being able to reconstruct a space on command anywhere. And when we say reconstruction, that means not only understanding the physical surfaces and the geometries, but also understand to a really high degree on what it feels like to actually walk around there. One way we say this is it's like being able to walk around inside of a photograph. That's actually being able to support asking questions, not only in terms of how to understand what's going on at this location right now, but maybe even looking into the future and trying to make predictions or support decision-making. In terms of how we think large geospatial models can be really powerful for the future of spatial computing, we think it has tremendous applications for any application where you're supporting decision-making. That could be disaster response, it could be architecture, engineering, construction, augmented reality, in support of all sorts of autonomous agents. So looking into the future a little bit, still very early days, but if we think about those three initial questions of supporting where am I, show me something, and tell me something, one of the big ways that it's going to change is being able to do more with less. So today, as we look through a lot of the technologies that are supported by spatial computing today, typically you need to have a lot of data collected about a specific area in order to understand where am I, to understand and see the location, be able to semantically understand information about that location. In the future, just the same way that an LLM can answer a question that's never been asked before, we believe that large geospatial models will be able to answer questions about the real world, even if there's not very specific recent data about those locations. So it's sort of like a level of superhuman intuition that can be applied to spatial understanding. I think another way that this is going to change has a lot more to do with like not only like what was the past like and what is the present like, but also being able to look into the future. Being able to ask a lot more hypothetical questions, and this gets much more into planning. And with the rise of robotics and autonomous agents, to a greater and greater extent, these types of systems will be able to make predictions and then actually take actions to make those predictions come to life.